Hi, I'm going to have a look at Markov chains and I'm going to use them to make some drum patterns, which will be fun. So what is a Markov chain? So the definition on Wikipedia is a Markov process is a stochastic process that satisfies the Markov property, sometimes categorized as memorylessness. In simple terms, it is a process for which predictions can be made regarding future outcome based solely on its present state. A simple Boolean example would be that if you lost countless times at a blackjack table, the next time you play, you're likely going to lose. A first order Markov chain is the most simple. A first order Markov chain uses the current state and learned probabilities of transitions to predict the next state. For this, we need two things. We need the finite set of states, and we need transition probabilities for the transition of one state to another. So here in this example, I'm going to look at predicting the weather. So what we need in order to predict the next state is the probabilities for all of the transitions for the current state. And then we use those probabilities for the current state to randomly predict the next state. And then we update the current state and repeat. Here in this predict weather function, we're going to make X number of weather predictions. So we're going to get the probabilities for the current state, and then we're going to make a weighted probability choice using this function here, which has a random generator and then iterates through the probabilities until the cumulated probability exceeds the random generated number. And then from that process, we can get the next state, and then we just repeat it. So here's my chain of predictions: sunny, cloudy, sunny, sunny, cloudy, rainy, cloudy, cloudy, rainy, 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 cloudy, rainy, sunny. The main limitation of this process is it lacks memory. So if there is some pattern in the chain of events, your prediction will have no knowledge of any such pattern and it will just blindly make its predictions. But it still has its usefulness. Moving forward, we go on to a second order Markov chain. And the difference with a second order Markov chain is it has a little bit of memory. So instead of just using the current state, you use the current state and the previous state in order to predict the next state. In this example here, there's just a random bit of text. So same as with a normal Markov chain, we need a finite set of states and we need transition probabilities for moving from that state to the next state. In this example, first of all, going to tokenize this string of text. So we have the, cat, and so forth. And then we're going to analyze it. So we will see that when the and cat appear together, we have the cat transitions to the word sat here. And we also have the cat transitions to the word chased. So in the second order Markov prediction model, whenever the word the and cat appears, we'll have a 50-50 chance of the next word being either sat or chased. And so we merely iterate through the tokenized text, and for every pair of tokens, we build up a probability of what the next word will be. And so here is the end outcome. We've got the word pair of the and cat can transition to the word sat, or it can transition to the word chased. And then based on that built up model of transition probabilities, we can then just generate text. So here's some generated text from this second order Markov chain. Sat on the mat, the dog sat on the log, the cat chased the dog. Not bad. I'm going to try and use this process to generate drum patterns and see what happens. So here is a fleshed out script that uses the exact same process as the weather prediction model and the sentence prediction model. I am inputting a drum pattern as a tab, and then I am tokenizing it. We build up the model, the Markov model being a finite set of all of the states, as well as all of the probability transitions from one state to another state. And then once that model has been generated in the task loop, we just use the model to generate the next state. So first I'm going to do a first order Markov chain, and I'm going to use this basic drum pattern here. Let's see what that sounds like. So we can hear the variation being created. So now the second order Markov chain. There isn't enough variance in the input data for the second order Markov chain, but what we can do is we can use input data with more complexity. Instead of a basic drum pattern, I'm going to use this So, in conclusion, Markov chains are an interesting bit of probability maths that can be used to make predictions and add a bit of variance to patterns.